June 19th, question number 9. The expression sine of 57 degrees is equal to. Well, one thing to remember about sine and cosine is that in any triangle, the sine of one angle will be equal to the cosine of its complement, meaning the angle that adds up to 90 degrees. So all we really would need to do here is to remember that sine of 57 will be equal to the cosine, and then take 90 degrees and subtract. And we are going to get 33 degrees. Now, this is also a really easy problem to check with your calculator, right? So if you just go to your calculator and put in the sine of 57 degrees and hit enter, and then put in the cosine of 33 degrees, you'll notice that they're the exact same number. June 19, number 22. A 12-foot ladder leans against a building and reaches a window 10 feet above the ground. What is the measure of the angle to the nearest degree that the ladder forms with the ground? Well, once I realize that we have a right triangle trigonometry problem, I like to just sketch a triangle here. I'll put a little triangle here. And I'm going to remember that ladders are always leaning, so that is going to represent my hypotenuse. And something that is 10 feet above the ground is going to be the vertical leg. Here's my right angle. And the question here is, to the nearest degree, what is the angle that the ladder forms with the ground? So my angle is going to be down right here. Okay, so now I'm going to begin the basic trigonometry problem. If this is the angle, that's my point of reference. I like to do my bow and arrow and shoot it across. This is going to be my opposite side. And the hypotenuse is always the hypotenuse. And down here is my adjacent. Now, whenever I do a right triangle trigonometry problem, I'm always thinking of so, ka, toa. And out of the O, A, and H, I'm always going to eliminate one of those sides, right? Because I'm only using two sides in right triangle, not trigonometry. So obviously I don't need my A because there's nothing down there. So with an O and an H, this is going to lead to a sine problem. I'm always going to attach the angle that was my reference, which is x in this case, will be equal to, and so katoa also helps me because it helps remind me of what goes on the top, in this case the O, and what goes in the bottom, the H. So the numerator of my fraction will be 10, and the denominator will be 12. Now, if you remember the three scenarios that could occur, sometimes x ends up on top of the fraction, sometimes x ends up on the bottom of the fraction, but in this case, x is the angle. So in this case, I'm just going to rewrite sine equals, no, I'm not. I'm going to go back. I'm going to write x is equal to, and I'm going to bring the sine to the other side, raise it to the power of -1, which is the inverse of sine, and I'm going to drop down the fraction right into the parentheses. Now I'm going to go to my calculator, and to get to the inverse function, we hit the second button, sine, and then just put 10 divided by 12, enter. And we see it's 56.4 degrees. This said to the nearest degree, so it's going to be x is equal to 56 degrees. Oh, there we have it. June 19, question number 27. A support wire reaches from the top of a pole to a clamp on the ground. The pole is perpendicular to the level ground and the clamp is 10 feet from the base of the pole. The support wire makes a 68-degree angle with the ground. Find the length of the support wire to the nearest foot. Okay, I'm going to treat this one as if I was actually taking the test. So I'm going to use my straight edge. I realize I have a right triangle trigonometry problem. So I have my pole, which is perpendicular to the ground. Say this is the ground here, right? You got your ground, right? Here's the pole. And it's saying that there's a wire that goes from the top of the pole down to the ground. And because that pole was perpendicular to the ground, right, this whole thing creates a right triangle, right? So let's get some of these numbers in. So the clamp is 10 feet from the base of the pole. That means that this distance from, say, here to here, right, it's going to be 10 feet, right? The support wire makes a 68-degree angle with the ground. Here's my 68-degree angle with the ground. And find the length of the wire. Well, the wire went from the top of the pole to that clamp in the ground over here. So that means that that is what we're looking for. There's my x. Well, now we're going to start our right triangle trigonometry problem. I'll write down soga toa for my reference. So, ka, toa. And now here's my angle. I'm going to shoot my arrow across. That gives me my O, or my opposite side. The diagonal is always my hypotenuse side. And down here, we always have our adjacent side. Now, in this case, the side that I do not need is going to be my O. There's nothing there. I need my A because I have a number 10, and I need my H because that's what we're looking for. That's my X. So with an A and an H, ka, that's going to be a cosine problem. It's always the function of the angle, 68 degrees, will be equal. And in this case, if I go back to the ka, it's the A over the H. My A is 10, and my H is the X, what we're looking for. Now, if you go back and remember the three scenarios, this is the scenario when X ends up on the bottom. And if you remember Mr. Frank's volleyball trick, I'm going to take that 10 and throw it to the other side, and my 10 is going to end up on top of the cosine 68, or 10 divided by cosine 68 will be equal to my x. So now I'm going to bring up my calculator and put in 10 divided by cosine 68 and hit enter. And we're going to get 26.69. Here it says to the nearest foot, so the nearest whole number, so that's going to round off to 27. So x will be equal to 27 feet. Okay, June 19, question number 19. Okay, number 19. Nick wanted to determine the length of one blade of the windmill pictured below. He stood at a point on the ground 440 feet from the windmill's base. Using surveyor's tools, Nick measured the angle between the ground and the highest point reached by the top blade and found it was 38.8 degrees. He also measured the angle between the ground and the lowest point of the top blade and found it was 30 degrees. Find and state a blade's length, x, to the nearest foot. Okay, so in this problem, we need to remember to stick to right triangle trigonometry. So this is a compound problem because we're going to need to do at least two problems to get to our final answer, which is going to be x. So if I were to draw in some helping lines in this picture, I'm going to look at that 38.8 degree angle. And if I use right triangle trigonometry and I use that 38.8 degree angle, I'm going to end up with the length from all the way up here, the top of that angle, all the way to the bottom over here, right? So let's just call let's just call that Z. Now, if I use that 30-degree angle, that 30-degree angle just goes right up to here. So I would end up finding this part right here. Let's just call that y. And now, if I wanted to find out x, which is really what they're asking, I'm going to have to know what z is, the whole entire length of that side, and subtract the y. And that would be equal to my ultimate answer, which is x. All right, so let's begin by finding z, okay? All right, so to find z, I'm going to use the 38.8-degree angle. Here's my bow. I'm going to shoot it across, so that's going to be my opposite side. And down here, I have my 440 feet, and that's going to be my adjacent side. In this case, we don't need our hypotenuse, so I'm not even going to write it. So if I go back to my general reference, so, ka, toa, this is going to be a problem with O and A, so it's going to be a TOA or a tan problem. So in order to find side Z, the tan of 38.8 degrees is going to be equal to side Z, my O, over my A, which is 440. And now we have a situation where our x, or our z in this case, is on top. So in this case, I'm going to cross multiply. I'm going to put the tan of 38.8 over 1, cross multiply, and get z is equal to 440 times tan 38.8. And now I'm going to put that in the calculator. Now, they want the answer to be to the nearest foot. So one thing I'm going to do is when I put 440 times the tangent of 38.8, enter, I'm going to round off to the nearest hundredth, like 2 places more than what they're asking. So I don't, by accident, at the end of the problem, round off to the wrong foot. So I'm going to say that z is 353.77. 353.77 for now. Okay, now let's go on and find y. Now for y, we're going to use tangent once again of 30 degrees. And the tangent of 30 degrees is going to be my y, my opposite, over my adjacent, which is 440. Again, y is on top, so I'm going to do the simple cross multiplication and get y is equal to 440 tan 30. Y is equal, I'm going to bring up the calculator and put 440 tan 30. Enter. And rounding it again to the nearest hundredth, it's 254.03. 254.03. Now, all we need to do is go back and substitute. So I'm going to say my z was 355.77 minus, and our y was 254.03. So we can go back to our calculators now, and we can say 353.77 minus 254.03, enter. We get 99.74. However, they did want the answer to be to the nearest foot, so that will round off to 100 feet. So x is equal to 100 feet. And there you have it. January 19, number 13. From a point on the ground 1/2 mile from the base of a historic monument, the angle of elevation to its top is 11.87 degrees. To the nearest foot, what is the height of the monument? Okay, now in this case, it's not that difficult of a question. However, they are referring to one of the quote-unquote sides as a 1/2 mile. And we can see that the ultimate question is wanting to the nearest foot. So we do need to make a conversion here. Now, if we go to our math reference sheet, they do tell you that 1 mile is equal to 5,280 feet. So we quite simply, by going to our calculator and putting 5280 divided by 2, we can know that a 1/2 mile is 2640. So 1/2 mile is equal to 2640. Okay, so now let's go back to the problem. So again, you need to realize that you have a right triangle trigonometry problem. So we're going to put a right triangle here to help us out here. Here's my right angle. Now, so the key word here is on the ground, right? The ground helps me know that 2640 is going to be down there on the ground. That the angle of elevation is going to be 11.87 degrees. It doesn't matter if my picture isn't really to scale. It's just really to help me to work this out. To the nearest foot, find the height. Heights are always the vertical side, so I'll put my X right here. Now we're going to go back to our famous so, ka, toa. I'm going to do my bow and arrow and say that, okay, that X is going to be my opposite side, and down here, this is going to be my adjacent side. Remember, the two legs of a right triangle will always be the O and the A. The diagonal is always the hypotenuse, which again, I don't need in this problem. So with an O and an A, that's TOA, that's going to be a tangent problem. So the tangent of 11.87 will be equal to my O over my A, my X over 2640. This is, again, an X on the top problem, so I'm going to quite simply cross multiply and say X is equal to 2640 tan 11.87. Take out my trusty calculator. 2640 tan 11.87. Enter. We get 554.8917314. This is a multiple choice question. And we could see to the nearest foot, that's going to round off to 555. January 19, number 17. In the diagram below of right triangle ABC, AC is 8 and AB is 17. Which equation would determine the value of angle A? So they're really saying, well, how can we figure out angle A? But then they don't actually want us to find it. Rather, they want us to be able to set it up. So this is a problem that's going to involve, clearly, right triangle trigonometry. So I want to write down my SOHCAHTOA just to have it out. But also I'm going to realize that in this particular case, they're giving me a right triangle with two different sides, which means I could find out the third side, which will be helpful here, side BC, by using the Pythagorean theorem. Remember, right triangle trigonometry always involves two sides at an angle, while the Pythagorean theorem also gets involved in right triangles. However, it's when you have two sides and are looking for a third side. So I'm looking for one of the legs. So I'm just going to write down here in my scrap, a squared plus b squared is equal to c squared. 8 is one of my legs. The b is going to be the other one I'm looking for. My c squared, which is the hypotenuse, is equal to 17 squared. 8 squared is 64 plus my b squared is equal to 17 squared. If you're not sure what 17 squared is, you go to your calculator, 17 squared, and you get 289. Our b squared is equal to 289 minus 64. B squared is equal to 289 minus 64, which is 225. The opposite of a square is a square root. And we get b is equal to 15. I'll put that 15 in there. Now, you also could have known that this is a very famous right triangle, and this is a Pythagorean triple because all three sides are rational. So this is an 8, 15, 17, right triangle, which is a famous one. Okay, so here we go. Now we have all three sides. It'll be easier to help us determine which function will work. Now, let's look at number one. Let's do one at a time and see which one works. Now, if we do the sine of angle A, we know that sine is an O over the H. Well, from the angle, we could put all the O, A, and H's down. From the angle, if I go opposite, that's going to be my O. The 17 is going to be my hypotenuse, and the 8 is going to be my adjacent. So if I do the sine of angle A, it's going to be 15 over 17. So we know that number one is not good. Let's go to number two. Well, if we do the tan of angle A, the tan of an angle is your O over your A, your opposite over your adjacent. So in this case, it'll be my 15 over 8. So this one also would not be right. Now, if we do the cosine of angle A, cosine means the A over the H. Well, my A is 8, and 17 is my H. That would be 8 over 17, so that one is not right. So let's hope that this last one is correct. The tan of angle A would be the O over the A. It would be my 15 over my 8, and that one, sure enough, is the right answer. Okay, all right, we got a big one here. All right, let's take a look at this. January 19, question number 34. As modeled in the diagram below, an access ramp starts on flat ground and ends at the beginning of the top step. Each step is 6 inches tall and 8 inches deep. If the angle of elevation of the ramp is 4.76 degrees, determine and state the length of the ramp to the nearest tenth of a foot. Okay, that's the first question. And there's another question. Determine and state to the nearest tenth of a foot the horizontal distance d from the bottom of the stairs to the bottom of the ramp. Okay, let's do one at a time here. All right, let me extend this a little bit and bring this down so we have some room to work. All right, here we go. All right. A few things as we get started here, right? We're going to determine the length of the ramp first, right? So I'm going to say, let's call the ramp here my x, okay? Now, there are a few calculations we need to make before we begin, right? This is a right triangle trigonometry problem. I can tell because there's an angle involved, right? So I'm going to just put a little SOHCAHTOA over here as my reference. I always like to have that handy. But I also noticed that that they want the answers to the nearest feet, right? The nearest tenth of a foot, nearest tenth of a foot. Yet they're giving me a whole bunch of dimensions here and lengths here in inches. So I am going to make some early conversions into feet, right? So one thing I'm going to do here is I'm going to try to change this into some right triangles. So I'm going to go to the very top of the ramp here and draw a line down here. And since I already have the angle, which is 4.76 degrees, I know I could find x, the ramp, if I knew at least one of the sides. So I could see that if this right here is 6 inches, and this is 6 inches, and this is 6 inches, that I could find that side opposite my angle by adding 6 plus 6 plus 6, which is 18 inches. But converting it to feet would require that I can divide that by 12 inches, right? 18 inches divided by 12 will give me the height here. And 18 divided by 12 is going to come out to 1.5 feet. All right, I think I now have enough information to find the ramp. So if we go back to my angle and I shoot my arrow across, I'll see that that 1.5 feet is going to represent the opposite side of that right triangle, right? Here's my right angle here. And the x that I'm looking for is going to be the hypotenuse. So this is going to be an O and H problem, which is a sine problem. So I'm going to say that the sine of 4.76 will be equal to my O, which is 1.5, over my ramp, which is my x. Now I see I have, out of the 3 scenarios, an x on the bottom situation. So I'm going to do that famous Mr. Frank's trick, the volleyball trick, and end up with the 1.5 divided by sine 4.76 equal to my x. Go to my calculator and say 1.5 divided by the sine of 4.76, enter, and I get 18.076178886. It says to the nearest tenth of the foot, so my x is going to be 18.1. 18.1 feet, right? And that is my ramp. Okay, but we're not finished. We're only halfway done here. So on the bottom, there's another question. Determine and state to the nearest tenth of it the horizontal distance d from the bottom of the stairs to the bottom of the ramp. Okay, so here we just have one slight little problem. Now, we already used x here, so I'm going to use y, but I'm going to use y to talk about the distance from all the way over here to all the way over here. I'm going to say, well, this is, say, y. And I could figure out this little distance from, say, here to here by adding 8 plus 8, which is going to be 16 inches, but I'm going to be dividing that by 12 to keep that in feet. Now that's going to give me 1 and 4, which is going to be 1 1/3. And since that's like a repeating 3, 3, 3, 3 in my calc, I'm just going to keep it as 16 over 12 for now. Okay. All right. So let's see if we can find y. Because if I can find y, which is the side of that big right triangle that I created, I can just subtract the 16 over 12, and that should leave me with d in feet, right? Because 16 inches divided by 12 is converting that into feet. So let's see if we can solve for y. Right, so I'm going to just bring this up a little bit here. Right, here we go. Okay, so in this case, I'm still going to use that O side, which is that 1.5, but in this case, I'm going to be looking for y, which is going to be my adjacent side. So this is going to be an O and an A problem, which is a tan. So I'm going to write down here the tan, again, of 4.76 is equal to 1.5 over my y. And now I see that once again, I have y on the bottom, so I'm going to take that 1.5 and throw it to the side. I'm going to end up with 1.5 divided by tan 4.76 is equal to my y. All right, go to my calculator, and 1.5 divided by tan of 4.76 is equal to 18.01. I'm going to leave that number in my calculator. I'm going to show you why. Because I know that my D is going to be my Y minus this little part over here, which is 16 divided by 12. Well, it's going to be more accurate for me to use my calculator over here just because I already have my Y right there. So I'm just going to subtract 16 divided by 12, enter, and I'm going to get 16.7. D is equal to 16.7 feet. And there you have it.